Hello, this will be a tutorial for Exponentials unit. The topic I've chosen is like the financial applications of it. We didn't spend a ton of time on the financial side of things, and I've noticed that the government gives these a lot of attention, meaning that it's probably a high diploma probability. When it comes to these things, it's in the exponential section because compound interest is an exponential idea. So money grows exponentially when you put it in an account. Unfortunately, on debts too, if you owe money, chances are the fees you're paying grow exponentially as well. So when we're given a situation like this, you can read through the question. It says here that Paula put $1,500 into account. It's compound interest. It's paid annually. Be really careful with that. If it's paid, semi-annually, etc., and you're putting it into the equation, you need to divide the number of compounding periods, but we don't have to worry about that here. And we're given the amount of money she has after 4 years in a table. A is asking us to explain how Paula can determine the exponential growth function. Okay, so I always say, try these yourself. So maybe pause the video and give this a try. Try and do this question yourself. It's actually not so hard. Come back to it and then see how I did it and how you're supposed to do this. And the rough answer for A is with a regression equation. So you basically get the calculator to find the pattern for you, which models the growth. And how you do that is you take your TI-83 and you would go put this table in under edit. So you go to stat, number 1 is edit. I'll bring this down. I know there's a bright spot up there, unfortunately. Go to edit and throw the values in. So if you go to edit, you can see I've already done that. So in L1, which is my X, that's time, that's manipulated variable. The responding variable is the amount of money in the account. So I've got that in under L2, which is my Y variable. Throw those into the calculator and then perform a regression on it. For financial, it's always going to be exponential. So go back to stat, go over to the calc menu, which is calculation, and you'll see all the regressions there. We want exponential, which is 0. So go down to exponential regression, hit enter. The calculator is doing its best to come up with this equation that models the growth of this account. And I'm going to write that out for you. That is y equals 1499.99, which is basically 1,500 for my A value. And then my B value is 1.04. And that's to the power x. So that equation tells me the growth of this account. So that's basically the answer for A. This is how it can be done. Now B, it's asking what's the annual interest rate. I explained this, that if this B value here is at 1, this thing controls the growth. So if this B value is exactly at 1, then there's no growth in the account, because 1 to the power of anything is just 1, so the account doesn't grow at all. The only part that is growing here is the part that's above 1. This 0.04 is my interest rate, and that basically equates to 4%. Every time I compound this, so every compounding period, this thing is going to get 4% bigger. So the interest rate in B is this part of the B value right on the end there. So the answer to number B is it's a 4% annual interest rate on the account. For C, to figure out how much is in there after 10 years, you could graph this thing and do intersection, and I've done that. I did that before and got the answer for it. A faster way to do this is if you want it after 10 years, the X variable is our time, right, and the Y value is our amount. So if we take 10 and substitute that in for X, that will be 10 years. So if you go 1,500 on your calculator times 1.04 to the power 10, that will give you the amount in the account after 10 years. And let's do that then. So first, by order of operations, remember bed mass, you do your exponents first. So put this in, and that's the power symbol, the little hat thing. And you put it to the power 10. So do that, and last, now you're going to do your multiplication last. You're going to multiply that by 1,500. And that gives you 2,220. So after 10 years, This particular account that she put in is going to be worth $2,220 after 10 years. Okay, I feel like this is a pretty typical problem, something you would see, and you can see that if you actually go through some of these, they're actually quite easy. We really didn't do a lot, right? We did most of these steps were in 5 seconds, and the calculator did most of the work. The key is knowing when to use what. So I hope that helped. I'm hoping to put up more videos on exponentials, and I'm going to put up a logarithmic video as well, so you can check that out. Thanks for watching.